Ready to open the second session of this conference, and it gives me great pleasure to introduce Antonio Sgamellotti and Bruno Brunetti for many reasons. First of all, because already one of the themes in this conference has been sort of a reflection about a certain tradition of excellence in scientific research and cultural heritage that the Italian school has demonstrated, and we have here two of the prime examples of really the founders and nurturers of una scuderia, of a team of really excellent practitioners in the field. In addition to this, Professor Sgamellotti is here as a representative of the Accademia dei Lincei. We're here at the Accademia dei 40, so it doesn't get more prestigious in terms of scientific heritage in Italy. And so to be welcomed as a community of scientists that work on heritage in some of the temples of scientific research, I think is a great signifier of how far this area of research has come. So without further ado, I am going to leave them the podium, and then we'll come back here promptly in half an hour, so you'll know that your time's up. Yeah. Thank you.
Thank you, Francesca. This mine will be an experiment. For the first time in my life, I will speak without slide and being seated. So I don't know about the success of the experiment. This talk is a two voices one. My voices, of course, and that of my colleague and friend Bruno Brunetti. I will touch briefly three items, giving just a few flashes without being too much comprehensive. The foundation of the National Central Institute for the Restoration, ICR and OPD, development of diagnostic techniques, and innovation in restoration procedure after the Florentine flood of 1966. The foundation of ICR and OPD. In the 40s of the last century, two central institutions, l'Istituto Centrale del Restauro, ICR, e il Gabinetto Restauri, associated to the Opificio delle Pietre Dure, OPD, were established. Both institutions are dedicated to the preservation of cultural heritage with three mandates: conservation activities carried out in their own laboratories, research activities applied to preservation of works of art, and the professional education of young restorers at the Scuola di Alta Formazione. The ICR was founded in 1939 by Giulio Carlo Argan and Cesare Brandi. Brandi was the first director and is very well known for his volume Teoria del Restauro, a fundamental book in the restoration, I would say the Bible of the restorations, and it was translated into many languages. The origins of the OPD are quite old, founded in 1588 by Fernando I of the Medici dynasty as a manufacturing specialized in working the hard stones, le pietre dure. Following the international trend, a Florentine sovrintendente, a young one, Procacci, decided in 1932 to create a conservation structure, Gabinetto dei Restauri, associated to the Opificio delle Pietre Dure. It was the first modern restoration laboratory, at least in Italy, with an important role of the scientific investigation, especially through the use of radiography. The situation that certainly contributed the most tightening the collaboration between restoration and science occurred following the disastrous flood of Florence in 1966. There was a need to respond to seriously damaged artistic heritage that could not be addressed and resolved with traditional methods and technique. The collaboration of the scientists of many Italian universities, in primis those of Florence University, and various research institutes, like those of the CNR, became one of the fundamental channels for providing innovative and effective answers. For instance, the OPD hosted inside, since a long time, a lab, CNR INO, with reflectography instrument at the state of art. More recently, OPD hosted an INFN laboratory. INFN is the Italian National Nuclear Physics, with the first movable accelerator. The acronym is Machine, M-A-C-H-I-N-E, which stands for Movable Accelerator for Cultural Heritage in Situ Non-Destructive Analysis. This instrument was built in collaboration with the CERN. Development of diagnostic technique. The first diagnostic tests for artworks were carried out using laboratory bench instrument based on spectroscopy, microscopy, chromatography, and more recently, biology and also proteomics, thanks to the School of Naples, founded by Gennaro Marino. By the way, the first paper on these topics report the result of a collaboration project between the Marino's group in Naples and my group in Perugia. This technique have undergone over time relevant technological improvement with great advances in sensitivity, selectivity, macro sampling, in preparation of cross sections. Advances in optical fiber technology, miniaturization of electronic components, and developments of increasing performance of detectors allowed for transformation of bench-top instruments into lighted, portable device. The scientific Italian community gave a great contribution to the development of such portable instrumentations. Sebastiano Sciuti was the first in Italy to develop atomic and nuclear methodology to non-destructive analysis of artworks. He was one of the first to build the portable XRF instrumentation. He was in nuclear physics, and already as a student, he was very, very brilliant. Ettore Majorana, his professor of mathematics in Naples, says in a letter to his friend Gentile Junior, the son of the ministry Giovanni Gentile, Sebastiano Sciuti is one of the most brilliant students in my physical class I have in Naples. We have been having some campaign with Sebastiano, and he was very proud of this statement by Majorana. Sciuti was the founder of the archaeometry in Italy, and he diffused the new science in some international conferences held at the Accademia dei Lincei. In 1972, application of nuclear methods in the field of works of art, and in 2001, archaeometry in Europe in the third millennium. Some other Italian scientists gave relevant contribution to the development of XRF, both in point and image modality. Among the other, Seccaroni in Roma, Cesario in Sassari, Pappalardo e Romano in Catania, Longoni in Milano. Portable spectrometer equipped with optics in the near-infrared region, the FORS, fiber optics reflection spectroscopy, has been implemented and extensively used in the laboratory of CNR IFAC by Mauro Bacci and Marcello Piccolo. Mid-FTIR portable instruments were developed in the CNR ISTM and Smart Center in Perugia. The multi-near scanner device developed by the CNR INO group of Luca Pezzati is a revolutionary in the field of infrared reflectography. The first published experiment in the hyperspectral modality in the middle infrared was carried out at the Perugia lab on a painting by Alberto Burri, while tests in the near infrared were conducted on ancient manuscripts in the laboratories of the National Gallery of Washington. Innovation in restoration procedure at the after the Florentine flood of 1966. Relevant studies at the OPD by Mauro Matteini, head of the science lab, were successful in the use of ammonium oxalate for the conservation of lime artifacts and of sodium oxalate for the inhibition of corrosion in outdoor bronze artworks and archaeological objects. Very effective were the procedure applied by Enzo Ferroni, professor of physical chemistry and director of the University of Florence. Those procedures were based on the use of inorganic materials, ammonium carbonate, and barium hydroxide in aqueous solution. Starting from this work, new methods were developed at the Florence Chemistry Department and at the Center CSG, Center for Colloid and Surface Sciences, under the coordination of Piero Baglione. These methods are based on the use of innovative microemulsions and specific chemical gels. New laser application achieved effective and selective removal of andesite materials layer on stone and metal sculpture. These studies were carried out at the CNR IFAC by Renzo Salimbeni and Salvatore Siano through the optimization of laser ablation processes using neodymium YAG lasers. Before passing the microphone to Bruno, I want to present a recent initiative of the Accademia dei Lincei, the foundation in 2021 of the Centro Linceo di Ricerca sui Beni Culturali Villa Farnesina. The acronym is CERIF, and I am the director of this center. The mission of the center is to carry on research on cultural heritage with specific studies on diagnostic and resilience of the artistic testimonies of Villa Farnesina and similar sites. The CERIF has established a network of collaboration with qualified public and private entities. For instance, the main research institution in Italy, CNR, Enea, INGV, with the main museum in Roma, Museo Nazionale Romano, Parco Ecologico del Colosseo, with the Brucker Azienda and with the Metropolitan Scientific Department. Now, Bruno, the microphone is yours.
Thanks, Antonio. While Antonio has given a general overview of what has been the most relevant passages of the Italian research for the study and conservation of cultural heritage, I will move to the European context, and I will say something concerning the launch and development of a series of European projects in the field of research infrastructure that occupied practically the last 2 decades, because everything started in 2001 with the project LabStack. This series of projects have had an important role for heritage science in Europe, at least to my opinion, because they contributed to give an enhanced visibility to heritage science within the European research area. Then they gave a boost to the European research potential in heritage science, because for the first time have been open a specific program of access for heritage scientists in order to allow them to carry out their research projects, exploiting advanced competencies and instrumentation. And third, most important, this series of projects will lead next year to the implementation of the permanent European research infrastructure on heritage science that will find its location in Firenze, in the ex Manifattura Tabacchi, of which you can see there a picture, a photo picture. All these projects have been coordinated by Italy. The first project was coordinated by myself, a group of projects, LabStack, URTech, and Charisma. Then after the admission of IRIS, that is the name of the permanent future research infrastructure located in Firenze, within the ESFRI roadmap, coordinator became Luca Pezzati of the Istituto Nazionale di Ottica, and then now he took care of the preparation of the field for the final implementation that is now carried out by Vania Virgili, belonging to the recently created Institute for Heritage Science, l'Istituto per la Scienza del Patrimonio del CNR. What I will do in the course of my short presentation is just to give an historical storytelling on how it has been and why it's been possible to arrive to the establishment of IRIS, pointing towards the Italian contribution. All the story starts in 1998, I would say, with the Piano Triennale dello Sviluppo Universitario of the Ministry of University and Research of Italy. In that piano triennale, it was included a call for the creation of interdisciplinary center of excellences in the Italian universities. Interdisciplinary. So through this call, it has been possible in Perugia to create a center of excellence whose acronym SMART stands for Scientific Methodologies Applied to Archaeology and Art. That was a center for research and higher education that included 5 departments of the university: chemistry, physics, engineering, art history, archaeology, together with some laboratories of Consorzio Interuniversitario di Scienza e Tecnologia dei Materiali e some laboratories of the CNR, of the Consiglio Nazionale delle Ricerche. The first president of this center was Mario Torelli, a well-known archaeologist, that then after his dismission in 2006, Antonio became president. The mission of this interdisciplinary center of excellence was obviously to promote the cooperation between humanities and physical sciences. But I call immediately your attention on the fact, I have written there in yellow the things, that one of the relevant point of the mission of the center was the development of new methodologies and portable instrumentation for non-invasive in situ measurement. And this was from the beginning, from the birthday of SMART, the main characteristics. The fact that SMART had two types of laboratory. A laboratory composed by the various benchtop instrumentation available in the 5 departments of the universities and the various laboratories of CNR. And then another laboratory that was created at that time, consisting of a set of portable instrumentation that are listed here. You can see what they are. X-ray fluorescent was at that time a well-established technique. FORS, the fiber optic reflector spectroscopy, had already prototypes developed by Marcello Bacci in collaboration with the Opificio delle Pietre Dure. The others were assembled for the occasion through cooperation with the JASCO, that is a company producer of instrumental equipment. Okay, this was the first mobile laboratory created in heritage science. Now there are several, I would say, mobile laboratories. And the motivation to create MOLAB is evident to all of once. The real secret motivation was the fact that we were conscious, we were aware that through MOLAB we had the possibility to have in our hands a good key to establish rapidly cooperations with museums, conservation institutions, and so on. In fact, immediately we established collaboration with the superintendenza, local superintendenza in Perugia. And in this picture you can see one of our first intervention on a gonfalone in the Museo Diocesano di Gubbio that was attributed to young Raphael. And Salvatore Sciuti, mentioned by Antonio, was together with us. And later, in collaboration with the Opificio delle Pietre Dure, we were called to participate to a campaign that was carried out as a preliminary to a manutention intervention on the David of Michelangelo in the Galleria dell'Accademia. In this occasion, Costanza entered in the CNR in Perugia and became member of our group, and you can see he is on the scaffolding together with other researchers. But this is the premise. What rendered it possible to undertake the first steps towards the creation of IRIS was in the fact the passage from the second to the third millennium. In passing from the second to the third millennium, within the European research program context, the fifth framework program was operative at that time, were introduced relevant novelties, new millennium, new things, new programs, new perspectives. And so starting from the fifth framework program, research infrastructure were no more considered only large-scale facilities as it was up to that moment, but also small and medium-sized facilities, provided that they had some unicity. Intended for unicity, for example, the possession of instrumentation or methodologies that were not available in any other institution. And another point was that another innovation, that research infrastructure up to that moment were created only in the ambit of physical sciences. Instead, from the fifth framework program, not only became possible to create new research infrastructure in Europe, but they were encouraged to be created in all the various strategical fields of the European research, including social science and humanities. So, within the Center Smart, there was some interest to start to undertake initiatives toward the creation of the future iris. And together with Mauro Matteini, that had a lot of knowledge around Europe at that time, we started to contact the Central Conservation Institute in Europe, museum, universities, research centers, and so on. And we found positive responses by some laboratories, such as the C2RMF in Paris, the National Gallery of London, of the Laboratorio Nacional de Ingeniería Civil in Portugal. But not only the institutions contacted were enthusiastic. Some of them had some criticism or perplexity, I don't know. Many of the people that contacted found that this idea to undertake a path toward a European research infrastructure in cultural heritage or in heritage science, as you want, was a quite bizarre idea. At the end, in any case, we succeeded. We knew that C2RMF was called by some French officer in Brussels to go to transform their accelerator located in the basement of the Palais du Louvre, Aglaé, in a European infrastructure. We knew everything from direct first-hand information through Antonio, that was member of some commissions in Europe, in Brussels. And this is the first group that was composed to start with the activities towards IRIS. Italy is present here, you can see. The University of Perugia was the coordinator. But also Opificio delle Pietre Dure and Istituto Centrale del Restauro, both the Conservation Institute of Italy, were present. And there was an Italian representative of the ICROM, that is an intergovernmental organization. He was Rocco Mazzeo, that dismissed from ICROM and passed to the University of Bologna and continued then as a member of the University of Bologna to cooperate within this. There was also another Italian, an honorary Italian, that was Marica Spring, as representative together with Ashok Roy for the National Gallery of London. And the Kikirpa was there, and other institutions. Also, the Getty Conservation Institute started to work with us. This network had substantially the goal to create the base for a scientific community of heritage scientists ready to accept and exploit a program of access to research infrastructures. And this, the project was successful, and within the following, it was opened the first European access program for researchers in cultural heritage that included two facilities open for access to external researchers. The so-called fixed lab that was practically consisting of the laboratory Aglaé, the large-scale facilities available within the basement of the Palais du Louvre, together with all the other instrumentation available for analysis in the field of organic and inorganic materials. And then MoLab. The second platform was mobile, composed by the instrumentation of the MoLab of the University of Perugia, integrated with the fluorescence imaging of the Opificio delle Pietre Dure and the infrared color scanner of the Istituto Nazionale di Ottica. Then the access was indeed successful. And in the following project, it was open another access to the archives of several institutions in Europe, including the National Gallery of London, the Opificio delle Pietre Dure, the C2RMF, the British Museum, the Prado, and the Agency for Conservation of the Netherlands. Then Fixed Lab was enlarged with the introduction of large-scale facilities. MOLAB increased the facilities available, including, for example, X-ray diffraction in a portable version, and so on. And passing through projects and projects, this is the current situation for the accesses open to heritage scientists within Iberian HS that will be closed in a couple of months. There is open access to the archives of 14 institutions in Europe that possess radiographies, images of paintings, objects, analytical data, the documentation reports, and also access is to samples. Large-scale facilities is coordinated by the C2RMF and include instrumentation given and offered by 23 institutions that offer 60, in total, 60 diagnostic tools for dating to analysis, including organic materials, proteomics, imaging techniques, and so on. And for the mobile version, coordinated by Costanza Miliani, that is now no more in Perugia, but is in Naples as director of the Institute ISP. 16 institutions are offering their mobile instrumentation consisting of 16-4-point analysis, multi and diverse spectral imaging, remote sensing, and what concerning the Italian contribution within the program for the archives, all of the Opificio is open. Concerning the large-scale facilities, there are 2 laboratories of the Laboratorio Nazionale del Gran Sasso and another laboratory, the LABEC of the University of Firenze. For the mobile instrumentation, there are practically 50% of the instrumentation, the mobile instrumentation belonging to MOLAB, now are belonging to laboratories of CNR and the University of Perugia. For the CNR, contributes laboratories from Catania, Perugia, Firenze, Lecce, and Potenza. Okay, so Francesca is looking at me. Now we are at the final phase. The future will belong to Iris. At the moment, on the 14 participants to the last initiative, 8 have already signed the ERIC agreement, that is the agreement that binds the Ministry of Research of the various countries to contribute and financially support the initiative. And we have just to wait next year in order to start. If Francesca gives me 30 seconds, I just say that one of the most important work developed by Luca Pezzati, he did a lot of work concerning this, was to create the premises to create, to transform Iris not in a European infrastructure, but a global infrastructure. Involving a lot of institutions from Asia, but also Northern American institutions, such as the Smithsonian, the Getty, and also Latin American institutions from Mexico, Argentina. Just to say, the first contacts with Latin American institutions were realized in La Habana, in Cuba, in 2007, and it was organized as a conference accompanied by a school on science and technology for cultural heritage. And there was the participation of Argentina, Brazil, Chile, Colombia, Cuba, Mexico, Peru, Uruguay. A lot of conservation institutions, of Latin American conservation institutions were there. I spent these added seconds just to show you this picture, and you can see from the faces of the people there that we had not only a lot of serious work, but also a lot of amusement. Just this for Lucia, that we're talking about. Okay, I'm finished.
Thank you very much. In the interest of time, we will leave the questions for later. I thank the speakers for their contributions. Also interesting because I couldn't help but notice, Bruno, in your presentation that the investment of the European community in this endeavor was about 53 million to establish an infrastructure in the spirit of the Europeans, or just sharing our resources, matching the Mellon investment of over 50 million to endow individual scientists at individual museums in the United States. That said, we will be moving to the Metropolitan Museum of Art, where Federico Caro is hopefully ready.
Can you see me?
Yes, we can hear you,
Oh.
Federico.
Let me share my screen.
That's great, so that I don't get judged against Antonio, who was always ahead of time, and I'm already running late on this session. Thank you.
Okay, could you see the screen? Yes. So thank you, Francesca, and thanks to all of you attending this workshop today. I'm extremely grateful to the organizing committee and to the Accademia dei 40 for giving me the opportunity to present today and being among so many esteemed colleagues and friends. I only regret that I couldn't make it to Rome, which is a much better venue than my office here in the ground floor of the museum. This office is indeed located on the ground floor of the Metropolitan Museum of Art, where I work as a research scientist together with other, I think, 14 colleagues, some of them Italians, in a daily dialogue with curators and conservators. The museum has 17 curatorial departments with study, exhibit, and care for the objects in the museum collection. There are also 10 different specialties in conservation at the museum. There is objects conservation, textile, paper, photographs, painting, costume, library and archives, arms and armors, and Asian paintings, as well as a time-based media group. The Department of Scientific Research collaborates with all of these departments to investigate materials aspects of works of art in collection, and works with designers, registrars, collection managers to guarantee the long-term safety of the collection. To do so, we take advantage of a suite of analytical instruments that favors, as has been mentioned in the previous talks, non-invasive approaches over the invasive, which when is necessary, is indeed minimally invasive. So for instance, here you see some example of instrumentation we have, and I just want to mention in the lower left, a tarot that is being analyzed by macro X-ray diffraction is something that will be featured as my colleague Federica Pozzi a little later. So how I got here at the Metropolitan Museum of Art. My journey started from the Department of Earth Science of the University of Pavia, and you see here an image of the department, which was, it is called, I think, still La Nave, because of its design, where eventually I was able to combine my two passions, the one for art and architecture, and the one for material science and technology. And I have to confess that I don't think I was an excellent student from the start until Professor Ugo Zezza showed me, it was professor of applied petrology, showed me how I could read my own town's cultural heritage through the lens of geology. And here you can see on the left, I showing the topic of my thesis dissertation, which is the beautiful and delicate Basilica of San Michele Maggiore. Understanding this intimate connection is what has been driving my interest in studies. Although I have to recognize that spending many summers helping my father in his motorcycle repair shop has also influenced the approach, the way I approach the study of works of art. So I need to thank him as well for that. If I have to cite what made a difference in my career and what eventually brought me here in your city, I have to cite the pursuit for and the participation to many international exchange programs and summer schools that put me in contact with different research environment, different mindsets and experiences. So Erasmus program for me was very important in learning, what was out of my small university circle. And indeed, it was thanks to 21 days that I spent on a Consiglio Nazionale delle Ricerche grants, the short-term mobility program, that I could learn about museum sciences in the US. And that's eventually why I end up here. So today, I would like to discuss about how scientific research enhances the experience of the public that choose to visit an art museum, particularly by focusing on the perception of color that I'm missing or have changed, which is something rather common for objects in museum, whether it's a faded lake in a Van Gogh painting, a hidden portrait of the Lavoisier that is not visible anymore, but it's there below layers of repaintings, or the lost patination of a polymetallic frog designed by Tiffany & Company. And to do that, I will talk about the work we've done for this exhibition. The exhibition Chroma, Ancient Sculpture in Color, gave us the chance, and I would say for the first time, to present scientific content in the gallery next to art historical information, and to give the public the possibility to look at objects from a different perspective. The flagship object of the exhibition was this Attic funerary stele, which features a youth and a young girl on its shaft, and has a capital and a final in the form of a sphinx. And the sphinx final that you see here reconstructed on the left is carved in the round from Parga marble around 530 BCE, and is one of the most extensively painted monuments in the Greek and Roman collection. And for this reason was selected by the curators for a new physical reconstruction in color that you see here by Vincent Brinkmans and Ulrike Koch-Brinkmann. The exhibition was not just about the Sphinx, but it gave us the chance to investigate many objects in the Greek and Roman art collection. Objects big, very big and small, produced from the 3rd millennium BCE to the 2nd century CE, and of different materials, such as copper alloy, ceramics, ivory, limestone, and of course, marble. And what was really important is that some of them were never studied, and we had the chance to look at them for the first time. Given the analytical, logistical, and time constraints, each object required a dedicated analytical protocol, often organized around the exhibition calendar and around curatorial needs. So that was quite a challenge. These protocols were designed to collect the greatest amount of information with the minimal intervention of the objects. So the majority of the analyses were performed non-invasively, and you can see here some action photos during the work done in preparation for Chroma, and some of the work could not even be moved from the cases where they were installed, so we have to work around that. Using a handheld X-ray spectrometer, for instance, which is a relatively common now instrumentation available in many museums, scientific research museums, laboratories, we surveyed the surface of the Sphinx in search for chemical elements that could be associated to specific pigments. So here, for instance, we were interested in the polychromy of the fly feathers and how colored alternated in the decoration of these elements. Pigment remains were imaged in the galleries using a digital microscope, which help us understanding application techniques and pigment mixtures, for instance. So here you see remains of cinnabar on the left and coarse azurite applied on the fly feathers on the right, but also provided the visitors with a direct evidence of pigments and colors, something that usually they cannot appreciate, and how they might have looked originally. And we use these images in the gallery a lot, and also for other didactic events. Similarly, we use other imaging techniques such as VIL to learn and, I want to stress, communicate about pigments that are not visible anymore with the naked eye. These images gave us very important scientific information, but are also quite powerful and stimulate the public's curiosity. And here you can see where Egyptian blue is present in certain specific elements of the flying feather and not in others. X-ray fluorescent mapping was also used to understand the design and color scheme of selected areas of the Sphinx. And when combined to complementary imaging techniques such as VIL, it was essential in discriminating between different, for instance, copper-based blues. In this case, azurite and Egyptian blue, both used for the decoration of the wings. With particularly Egyptian blue used to represent the light blue background in contrast to darker fly feathers. And here you can see another map, in this case of the crown, where its decorative pattern was revealed thanks to XRF. And again, we use these images a lot to convey information to the public. We all know that these non-invasive techniques provide preliminary information about polychromy, but often leave unanswered questions, such as how pigments were applied or whether or not pigments were mixed and layered. In this case, a microsample could contain wealth of information, even if it's less than a millimeter big. And here you can see a section of a small sample of the Sphinx hair with the marble surface on the bottom, the pigment layer, and the burial deposit on top. And this sample informed us that the color, the pigment was applied directly on the marble surface with no preparation, and that in this case, the red pigments of the hair consist of an hematite-rich ochre that contains traces of arsenic and scattered few particles of cinnabar as well. Such detail can be very useful when we want to correlate different objects. For instance, here we see a sample collected for the hairband of the chorus, which is exhibited in the same gallery of the Sphinx, that shows a marble surface where a hematite-rich ochre is applied directly on the marble without preparation. And interestingly enough, the morphology and the chemical composition of the hematite, which is arsenic-rich, is comparable to the one of the Sphinx. The opportunity of studying in detail several objects in the collection led also to unexpected discoveries, such as in the case of the 6th century BC horse head that bears traces of an uncommon type of Egyptian blue. And you can see here highlighted where the traces of Egyptian blue is found. You can see here. First analysis by X-ray fluorescence spectroscopy detected cobalt in high amounts of iron among the constituents of the pigment, which is something relatively unusual that convinced us to spend a little bit more time in studying it rather than rushing and providing information to the curators and conservators that were installing the exhibitions. A digital image of the pigments collected on the, from the objects shows its main constituents. You see the blue particle of Egyptian blue, the cupro-riverite, unreacted quartz, but also quite abundant dark angular particles that caught our attention. And you see here scanning electron images of this particle. And by the way, we had permissions when we were able to convince the curators that it was really interesting to collect a microsample. So that's why we are able to show these kind of images. And these are some of the black particles that you see on the left image using backscatter electron imaging. And you see they varies from single particles to aggregate of particles with an infill phase. Quite interesting. These particles were characterized as cobalt copper ferrites, which are relatively minerals that rarely occurs in nature, and that are likely the byproduct of the synthesis of these blue pigments. And you see here elemental mapping showing how iron, cobalt, and copper are directly associated in these particles, and there is an infill that has a very different composition. Unfortunately, I can't say much more at the moment about these findings as the project is ongoing. And we know that cobalt copper ferrites could potentially form during the dry synthesis of Egyptian blue, but we have no evidence right now confirming these hypotheses. Neither the possible sources of cobalt have been postulated. However, it is clear that understanding these particles and how they end up there could help understanding the technology behind the production of this specific Egyptian blue, such as which raw materials were used and which temperature the pigments were fired, and might even help reconstructing the trade of these particular pigments. Because what we know is that there is one other and only finding of cobalt copper ferrites in an Egyptian blue small cake that was excavated from a workshop in Kos. This is a later workshop, but you see here highlighted in pink a lump of Egyptian blue that contains the same exact copper ferrite. So it's not a unique occurrence, but it has been documented before. Now we have to understand why. So scientific investigation can really help us seeing works of art under a different new light. And for the exhibition, for Chroma, scientific data was used to guide the reconstruction of the ancient polychromy of the Sphinx. And you see here an earlier reconstruction of the 1980s and the new one that it was proposed in the galleries. But also, scientific data enrich the gallery labels, can reach the information that reach the public, and could reach the public in various ways, through labels in the galleries, but also through online and scholarly publications, and even through an application that was designed specifically for the phone, where public could play and discover pigments themselves. And so trying to be scientists for once in the galleries and seeing pigments for the first time. And last but not least, we had the chance to present our work through a successful program of gallery events and talks, where we experienced firsthand the excitement of adults and kids reading art through science. And I really want to stress that as one of our goals as scientists in museums, to reach for broader audiences. And with this last slide, I conclude and leave the floor to my colleagues. Thank you.
Thank you very much, Federico, for the very interesting talk. I'm lifting some thoughts that hopefully then Marco will pick up, but it's interesting that you mentioned that as part of your inspiration to get involved with heritage science was the terroir, so just being surrounded by historic architecture and seeing how your geological training could be applied to other fields of studies. And thank you also, as with the other speakers, for presenting both an experience in the galleries and some work in progress, which is the exciting part of doing scientific research in our field, that we often have more questions than answer. I've gained 1 minute on my 2 minutes delay on the schedule, and I am absolutely delighted to present our next virtual speaker, who's very close to me, as she works at the Art Institute in Chicago, Clara Granzotto, and very grateful that she's joining us today.
Thank you so much to the Accademia dei 40 for the invite, and thank you, Francesca, for the nice introduction. Can you all see my screen? Yes, okay, that's good. As Francesca said, I'm the Associate Conservation Scientist in the Conservation and Science Department at the Art Institute of Chicago. And I would like to start my presentation by talking about one of the latest projects I've been working on, which is about the characterization of painting materials on bois masks from Burkina Faso. So we are in Burkina Faso, West Africa, and the masks I've been studying are the masks that you can see on the right of this slide. So these are masks belonging particularly to the Bois people. They are usually made of plant fibers, but in this case, they are carved in wood. So Bois masks are usually two-dimensional. They have these characteristic geometrical patterns, and they are painted with three colors, black, red, and white, which evoke the three major rivers crossing Burkina Faso, the black, red, and white voltas. So these masks are used in different occasions. They are, for example, used during initiation of a new family member, during funeral, during the introduction of a new mask to the community, in connection of rites for the harvesting cycles, but also during performances in the market days, both for the villagers and nowadays for tourists. They are usually held by the dancer through a rope in their mouth, and they are then attached to a body costume, which is often made of plant fibers. So when we started this research project, we studied the literature, and we definitely got a lot of information about the possible materials that could have been used to paint these masks by accounts of scholars who worked in Burkina Faso. And among these scholars, I want to mention Christopher Roy, who has been working in Burkina Faso for over 40 years. So according to Roy's notes, for example, the black paint is prepared by boiling seed pods of the tree Acacia nilotica, or other time by using powdered charcoal, which was mixed with a binder such as egg. For the white, excrement of lizards or snakes were used, or simply some schoolroom chalk. Red instead consisted in iron-rich stones, such as hematite, mixed again with a binder that could be an acacia gum or egg. However, Christopher Roy, together with other scholars, also mentioned recently the introduction of more modern materials, such as enamels. So in this study, we combine spectroscopic and mass spectrometric techniques in order to better characterize these painting material. But we were lucky enough to be able also to get in contact with Abdoulaye Oudrago, who is an artist from Boni in Burkina Faso and an expert in mask making. So, of course, with scientific analysis, our goal was to corroborate and complement the information that we had from scholars. But by combining scientific information with artistic knowledge, we were really able to move a step further to really get a better idea, not only of the nature of the materials used, but also how they were prepared, selected, and applied. In addition, there is a sort of an impetus for scientific analysis, since there is a growing interest on bois masks from Western institutions and collectors. And so it's very likely that artists will move from more traditional materials to more easily available materials. So let's start from the black paint. When looking at the samples under the microscope, we could tell that this black paint was really had a really translucent appearance and more of a sort of a brown color. As we usually do, we start with a very fundamental screening technique, FTIR, and results show the presence of tannic acid, which was consistent of the use of some kind of tannin, so a plant-derived polyphenolic compound. And this was also confirmed by pyrolysis gas chromatography mass spectrometry, thanks to the identification of gallic acid and ellagic acid, which also helped us understanding a little bit of which kind of tannin we were dealing with. And in this case, because of these two compounds, we were dealing with hydrolyzable tannins. However, in order to corroborate the tannin source, as mentioned by Christopher Roy and other scholars, we decided to purchase some acacia nilotica seed pods and to do some cooking in the lab. So we boiled these seed pods in water for several hours. We took the extract, dried, and analyzed it by FTIR and pyrolysis. And the results were extremely similar to the results that we got from the black sample. And this was a confirmation of the use of tannin to prepare this paint material. However, we couldn't really understand why our extract didn't really look as dark as the black paint on the mask. And that's in this moment that our conversation with Abdullahi was extremely helpful, since he told us that usually the extract is then boiled even for several days in order to get a concentrated and darker product. So while with this experiment, of course, we couldn't determine and prove that acacia nilotica was the source of tannin, since tannins are present in many different plants. However, we were still able to support the account of the source of the paint and also the way of preparation. Moving on to the red paint, FTIR analysis and some EDS analysis confirmed the use of hematite. But the most interesting part of the story concerned the paint binder. So as you can see on the left, FTIR analysis indicated the presence of a protein-based material, but there were some features suggesting also some sort of lipiding compound, which could be related to an oil or most likely to, for example, egg yolk, which adds 30% content of lipid content. And this was sort of confirmed by pyrolysis, according to the proportion of the different fatty acids and the low level of azelaic acid. But maybe because I am an organic scientist, of course, I wanted to go further. And so we decided to move on with sort of kind of recent technique, which is mass spectrometry-based proteomics. As mentioned before at the beginning of this afternoon session, proteomics has been introduced in the field of cultural heritage a little bit less than 20 years ago. So it's a pretty recent field. And the great power of this technique is that we can get information not only about the type of proteins that we have, but also, if we are lucky enough, about the species of origin of the protein. In addition, this is an untargeted technique, meaning that we don't get information only about the proteins that we expect to find in cultural heritage samples, such as animal glue, egg, or casein, but we can see any kind of protein present in the sample. And this is extremely important when working with, let's say, non-Western materials that have not been scientifically studied as much as our common samples. And we were lucky enough to get a huge number of proteins. We saw some egg white proteins, egg yolk proteins, suggesting the use of all egg. And in particularly, these egg proteins were coming from a specific bird called the helmeted guinea fowl. I was not aware and I didn't know this bird, but apparently guinea fowl is native of Burkina Faso. And in one other red sample, instead, we found a mix of egg proteins from both the guinea fowl and the wild turkey, which is, of course, not native of Africa, but was introduced in Africa and before that in Europe during the 17th 19th century with the Spanish colonization. And again, here by talking with Abdoulaye, he mentioned that, of course, the use of eggs from guinea fowl is very common because it's present in the village, but sometimes in absence of these eggs, they will mix and use any kind of eggs, including eggs from wild turkey. And finally, the last paint material, the color white. So when looking at the masks, all the white areas looked pretty much the same, but scientific analysis really provided the greatest variety of materials. So in 3 out of 4 of the masks, we saw the use of kaolinite and gypsum, so most likely classroom chalk, without any binding medium, which was very, very surprising to us because we grew up learning that usually a paint material is a combination of an inorganic material mixed with a binder. And again, here Abdoulaye confirmed that usually the white pigment is simply wetted with a little bit of water, applied then with a finger or a feather to the surface. And because the wood used to carve this mask is very soft, this is enough to guarantee the adhesion of the pigment to the surface. However, for one of the masks, the fish mask, FTIR and the pyrolysis gas chromatography showed the presence of uric acid, which is consistent with the use of reptile or birds' excrement. So both birds and reptiles excrete nitrogen in the form of uric acid or its salt, so urate, on the contrary of mammals, which excrete nitrogen in the form of urea. And I'm pretty sure that a lot of you are familiar with the natural white pigment that you see on the rocks, on some rocks at the seaside. Application of proteomics then allowed us to exclude a bird origin of the excrement and suggested instead the use of lizard excrement, as suggested and read in the accounts of different scholars. And again, here when talking to Abdoulaye, he mentioned that these lizard excrements are collected in nature, for example, in the cave, but it's not common practice nowadays. And so again, scientific analysis was extremely helpful in this situation to distinguish masks where more traditional materials were used instead of more easily available materials such as gypsum, while from a first observation, these masks looked exactly the same. And so by combining information from scholars, but also information got during our conversation with Abdoulaye, and scientific analysis, we were really able to get a better understanding of the materials, of their use and application. And this research, with this research, we also want to stress how important it is when working with non-Western materials, when possible, to get in contact with the community, to be sure that we as scientists can actually investigate these artworks and in case publish the data. In the second part, I wanted to summarize a little bit my journey from the Ca' Foscari University of Venice to here, to the Art Institute of Chicago. It's a journey that required crossing the Atlantic Ocean several times and get adjusted to different languages, different food and bureaucratic systems. But definitely every step of this journey helped me approaching in the best way and understanding which was the next step necessary to become a conservation scientist. And so I wanted to touch and talk a little bit about some of these steps and the lessons that I learned. So as I mentioned, I studied in Venice. There was a program called Chemical Science for Conservation and Restoration. It was a 5-year program, so I did both my bachelor and master. And back then, so I started 2004 until 2010, we were under the chemistry department. And to me, that was very, very important, meaning that when I graduated, I had the title of chemist. This gave me, first of all, an incredible scientific background that then I used during my whole journey. I had a title that allowed me to sign up and apply to a scientific PhD. But also, to be honest, I had the possibility to have a plan B. When I was during college, I didn't know any conservation scientist. I didn't know if I could actually become a conservation scientist. So if I couldn't really reach my final goal, of course, I had a title that allowed me to go and work for a pharmaceutical company. I'm glad I didn't. Another important point of this program was the numerous conservation labs. We had labs of painting conservation, wall painting, metal conservation. Besides learning a lot of conservation procedure, the most important thing is that I learned a language that helps me now to discuss and interact with my colleagues in the conservation department, and also to build a fruitful collaboration with them. One thing that back then we were sort of missing was, however, kind of connection with the international context. As I mentioned, I didn't know any conservation scientists, and we were not aware of internship and fellowships abroad outside of Italy. And to be honest, the internship that I had at the Met and followed them by fellowship was the most eye-opening experience I ever had. For the first time at the Met, I met some conservation scientists. And so I realized that, yeah, maybe I could be one of them. I was able to work on several different projects to understand what I liked, to understand in which kind of aspect in the field were missing some research. And this helped me decide in which direction to take for a PhD. And also that I actually needed a PhD to become a conservation scientist. Another important thing in my career was the application to European fundings. I was lucky to be awarded Marie Curie individual fellowship. And the fact of going back to university really helped me to build a know-how and an expertise, which was very focused. But on the other side, I was able to get an expertise again that could be of interest for my future employer. Also, European fundings really help to have money to travel and so create collaborations and do networking. And I'm finally here at the Art Institute of Chicago, and I could have not done it without all these different steps. And so I want to thank everybody who I met in my path, and just a last picture to show how sometimes we end up sampling the object. And this is one of the masks I showed you before. Thank you so much.
Presentation. In the interest of time, we'll continue with the program, and hopefully some of you are here still during the roundtable. We can have a conversation. Just a couple of things that I wanted to highlight again in terms of your path. These themes of international collaboration and networking, and how formative that is for us in the field. I think it's also very important to underscore. And also, I certainly speak for myself, but I've heard Marco say this. It's not that we hire Italian scientists because we are Italian. We hire Italian scientists because they're really good. We also hire other scientists. And on this theme, let me introduce Monica Gagno, who's officially the speaker who has traveled the farthest to come here to Rome. And I'll leave the floor to you, Monica, to talk about your project and introduce yourself. Thank you.
Good afternoon, everybody. Can you hear me well? I'm Monica Gagno. I'm an associate scientist at the Getty Conservation Institute, which means I'm 9 hours out of my comfort zone, and it's supposed to be 6 a.m. for me right now, but everything is good. Today I will talk about archaeological glass, which is, I would say, my passion and something that has been constant in all my steps throughout the world. And so I will start by indeed talking about the path that took me to the Getty Conservation Institute. I started in Turin, where I studied glass over there, and I did the same program that Eleonora did. Indeed, we were classmates, Science and Technology for Cultural Heritage. I did both my bachelor and my master there. And I think that one of the biggest lessons I learned from that place is the solid foundation on heritage material and the fact that you need a perspective that is very coming from multiple disciplines to understand the complexity of the material. After this, I went to the Getty for the first time, and I did an internship there over a year. My supervisor was Mark Walton, and as such, I was lucky enough to continue work on some vitreous materials, but I was also exposed to many other materials, namely archaeological stuff for the majority, but also some more modern and recent issues, such, for example, the pink staining on marble that was a consequence of a past treatment. And over there, I think that the takeaway is the need of a good communication and understand the language and being able to express your point of view and understand what the conservator and curators are asking you and try to make the most out of it. To keep on working on glass, I moved back to the old Europe, and I moved to Leuven in Belgium, where I did my PhD on archaeological glass and understanding the provenance of archaeological glass and their raw materials. And that was mostly focusing on one aspect, a deep dive into it, and definitely learning to manage an independent project and be aware of my timing and how to deal with different organizations and institutions. I then was very lucky to go to Chicago, where I worked again with Mark Walton and Francesca at the New Access. Similarly, some more glass, but also very different materials, some archaeological and some totally non-archaeological materials, such as those modern sculptures, bronze sculpture. There, definitely, the word that comes to mind is multitasking, because one person, many different projects all together, so the ability to change very quickly what is your daily schedule. And then lastly, I am back at the Getty Center starting in 2015, where I work mostly in the archaeological section at the Getty Villa. And there, I would say the word is flexibility, again, for the reason that we really work in collaboration with the conservation department, and it really depends every day. Most of the time, if I have a plan, oh, today I will do this, surely it's not going to happen because a new thing comes in the lab, and so it's a switch, very quick switch. Having said this, I will go back to my project, the archaeological glass that I was discussing before, and as I'm not sure how much people in the audience know about glass, which is probably not the most common material that we discuss in these conferences, I will give a very, very brief discussion of this and say a few words. So glass is generally created in a two-step process. You have a first step where you mix the raw ingredients, being sand, a flux, and a stabilizer, and you obtain the so-called raw glass. This raw glass is generally not colorless. It's always has a pale tint, can be pale blue, pale green, pale yellowish, depending a little bit on the impurity of the sand. And then you have a second step, which is the glass working. That doesn't necessarily happen in the same location at the glass making, where the raw glass is melted again, and there are a series of metals that are added as colorants or decolorants, and you finally obtain the nice, pretty object that then we want to see. So this was the methodology used most throughout the antiquities, and it's very well known and characterized for Roman glass, but it was similar also before and even a little bit after. Now, the project in particular that I'm talking today deals with core-formed vessels, which are those iconic little glass objects, unguentaria, also very often called, which are very bright colored, most often blue with striation of yellow or white and turquoise and different patterning, very geometric. Those were produced in a relatively narrow time range, being between the 6th and the middle of the 1st century BCE. And they are very often called the Mediterranean group vessels. There were three main locations for their production that changes over the time, as I am indicating. So it starts in Rhodes, then moves to Magna Grecia, so southern Italy, and then moves to Cyprus. And these three large group, or mostly period, are often called Group 1, Group 2, and Group 3. And we are going to call and mention and so remember this knowledge very briefly. Those are some of the objects that I had the pleasure to study. They are all up to dimension, so you can see there are different shapes, different sizes, different colors, and different level of preservation and alteration given by the natural weathering. I want to stress one thing about the shapes. This, I would say, they are really the extent of the shapes that were produced, because throughout the 6th century, this group of objects are characterized only by 4 different types, which being the amphoriscos, the ariballos, the onyche, and alabastron. Now, to me, they look all very, very much similar throughout the century. Art historians will have a very different take. So indeed, I found a quote in one of the catalogs describing the object that was saying that the small dimension difference of the handle, it's clearly pointing to a 2nd century versus a 6th century, to me was absolutely not different and intelligible, the difference. So just saying different perspectives are important. The reason why we did this project was mostly to understand what was the colorants and the opacifier, and potentially understanding something better about the chronology and the composition, and say something about the provenance. This for 2 reasons. The first was a scholar named Tassos Antonaras, which is a prominent scholar in the study of archaeological glass, is currently writing a catalog of the glass collection at the Villa. And we worked together and we selected some of the objects that for him were a little bit more complicated to understand or to explain and describe, so to gather more information and help him in the dissemination, but also to get some better information in the near future, hopefully, on our website. So this is how a typical description of an object looks on our website. The description, it really is not very good. It says 200 to 1 BC, unknown artist, clearly. And if you look into the detail, it tells you the dimension. It says there is glass. That is potentially Greek, although culture, it's a little bit complicated because the objects that they get are classified as Greek or Roman. And it comes from Eastern Mediterranean, which is a very generic place for something that is a Mediterranean glass. So we would need to know a little bit more potentially. And then I want to discuss the analytical strategy. So I'm showing here a bunch of little fragments. This is what, when I first started to study glass, was presented to me. So I have a bunch of fragmentary material offered by university excavation or archaeological collection. And those are material that essentially are waste because no one could really use them to reconstruct a shape. So the amount of information you can gather is incredibly large for what concerns their chemical information, but there is a little bit of a lack in what is their shape, how it was created, what was the use of it, and so on. On the other hand, when we look at a museum object, like full, complete museum object, very, very often I don't have the luxury of sampling, hence I cannot do ICP-MS, I cannot do microprobe, I cannot do isotope analysis and all of this thing. And even laser ablation, most of the time I really can't do it because the object is too big to be placed inside the chamber. And in addition to this, if I look at a multicolor vessel, I will need to do multiple spots, hence create something visible to the eye. My institution doesn't allow it. So what I see is that instead of having a balance between these two situations, I actually have a bias towards material that is fragmentary, and I know a lot less about those materials that survive the proof of time, essentially. They have a complete history. So the idea was to try and use XRF, which has a lot of pros, but has a lot of cons in the study of glass, especially. We cannot have any information about light elements for real. So magnesium, potassium, aluminum, silica, all those elements that are really characteristic of the base glass are not going to be really well analyzed because of issue with the technique itself. On the other hand, I could steer the question that I was asking and just focusing on the colorants and opacifiers, so understanding the technology of the secondary workshop, essentially. And the way I decided to do was to do XRF on the object and then take the full spectra without calculating anything, literally this spectra, and throw it in a principal component analysis and do PCA on the spectra itself and try to see if this was enough to distinguish large categories. So here I'm showing some results. And I'm showing first PC1 versus PC2. I decided to stop at the first 3 PC that I will show in a minute, just because after that it became very noisy and it was really hard to see if it was something real or if it was just essentially noise. So the loading plots on the bottom right show me that I have some variations. So for example, PC1 shows a positive lead, while PC2 positive copper and a negative manganese. If I transpose this to my scores plot, you can see that there is some differentiation. The little dots you see correspond to the color of that I can see with my naked eye. Sometimes the color, for example, I'll give you an example. Here there are some white spots, which I think are actually indicative of an alteration of the glass itself. But you can see, for example, the yellow stay on their side, and then potentially you can say that the turquoise are on the upper section, while the purple are on the bottom and are richer in manganese, which is all kind of reasonable, but it really doesn't show me any wonderful groupings. I wasn't particularly pleased. So went along, did the same thing, PC1, PC3. The situation changes slightly, so we have a division between the blue and the white and turquoise, but now white and turquoise are overlapping, so it's again not completely clear. So probably a little bit better is when we start looking at this PC1, 2, and 3 together in a three-dimensional space. And we can see, for example, that the blue and the turquoise and the white are indeed separated on along PC2, but I overlap along PC3. The yellow are by themselves, and then the blue are kind of a mystery, which we're gonna discuss. So I'm showing just one example for the white and the turquoise. And for example, if I take into account the white, I would distinguish these 4 little clusters. If I look at a characteristic XRF spectra for such, I can see major differences, being the one that is in red is characterized by the presence of antimony, but especially by the complete absence of lead, which instead is what characterizes the other 2. This will suggest me that there is a change in the technology for the production of the color white. And more interesting, if I look at the chronology, this goes together with time period. So antimony rich in the earlier period and moving to lead rich in the later period. Similar thing happens to the turquoise, and this is kind of reasonable given that literature described the production of turquoise as the addition of copper to a white-based glass. Now I said the blue were a little bit more complicated or less clear, let's put it this way, and this is because they are spread a little bit and it's less clear. Now, if I think of how I produce the color blue, there are 2 main ways to produce blue in a glass. It's using the colorant cobalt or the colorant copper. Now, cobalt is added in very small amounts, in the order of 0.5 to 1% maximum, otherwise the color becomes so dark and deep that you don't have a transparent glass anymore. Copper instead, it's on a little bit higher concentration, but not particular, it's not a major element, it's still gonna be a minor element. Both of these colorants come in with a series of trace elements. Now, if I do XRF, and I need to look at a trace element, perhaps in the order of some 100 ppm, in something that is already only 1%, it's really hard, so I am missing all this information. And on top of this, there is one more thing to add, which is the extent and the role that recycling plays into the production of glass. Very similar to what we do today. If you look at this scheme, there is one part that I was keeping out, which is recycling. So as you would do today, and you would take your scrap of glass that are broken, put it in and recycle them, same thing was done in the past, even more because it was very time-consuming and material-consuming product. So they were trying to selectively introduce cullet of glass of the same color that it was produced. Now, You can easily understand that if you want to produce a colorless glass, probably you would not add a piece of blue glass into this, because then you have to work so much to get the color out. But if you do the opposite way and you want to achieve a blue color, honestly, if you put a little bit of this or a little bit of that, most likely it's homogenized by the darkness of the color. It's what was suggested and experimented by Jackson and Painter. They produced a modern replica of one of those vessels, grind it up, and then melt it again. And you can see in the grinding that there are some little bits of yellow, which, if you remember, were lead rich. When you do the melt, it comes out a color that is pretty much the same, but has higher content of lead. And so if I go back to the PCA analysis result, I can see that they're going towards positive PC1 have an increase in lead. And so I can hypothesize that perhaps those samples that are marching towards that direction are influenced by recycling. Now, this is the extent as the XRF can tell me for real, without crunching numbers and start doing some calibration and calculation of semi-quantification, which I really wanted to avoid because of the reason of not being sensible enough. And I hope I was able to show you that even with just an instrument that is not generally considered the best for this type of analysis, we perhaps can swing this bias and try to analyze and gather more information from museum object and increase our knowledge and everything else that they can tell us beside what we already know from little scraps of glass. This is a little video that I'm leaving you on the production of those core form vessels, which I think is very exciting, and I thank you all.
Thank you so much, Monica, for a fascinating talk. And again, I cannot fail but notice the squiggly career path that Gianluca Pastorelli also had in his graphic, as well as this emphasis on ability to communicate as one of the requisites for being a successful heritage scientist in a museum. And also, as Clara showed, this pattern of transatlantic crossing back and forth. And so it's wonderful to close this session with my colleague, Federica Pozzi, who has done this several times and is probably the most successful example of the rientro dei cervelli, the returning wave of the brain drain of Italian scientists, because after an illustrious career in the United States, she's now back in Torino at the Venaria, and this is also the title of her talk about building bridges. And so, Federica, here to you.
Thank you so much, Francesca, for this very nice introduction. The case study that I'm going to talk to you about today is actually very dear to my heart, and I will tell you everything about it in just a second. Just like my colleague speakers earlier, I was asked to introduce myself and share a brief overview of what were the fundamental steps that brought me where I am today. So I'm going to try and do this in one slide. So between 2003 and 2012, I got my Bachelor of Science, Masters of Science, and PhD in Chemistry and Chemical Sciences from the University of Milan. That was probably the place where I had my first work experience in an analytical chemistry laboratory. And where I got acquainted with several spectroscopic and chromatographic techniques. As part of my PhD studies, I was lucky enough to spend 1 year working in the Department of Scientific Research of the Metropolitan Museum of Art, where I worked with Marco on the development of methodologies and databases related to a particular analytical technique called SERS, Surface Enhanced Raman Spectroscopy, that is particularly suitable for the ultra-sensitive detection and identification of organic colorants in works of art and archaeological samples. In 2012, I had an appointment jointly with the chemistry department at the City College of the City University of New York and the DSR department at the Metropolitan Museum. So I was able to continue my research on the development of source methodologies and databases with applications both to conservation and conservation science, and also to the field of forensic science. Between 2012 and 2014, I was a postdoctoral fellow in conservation science, working with Francesca at the Art Institute of Chicago. My focus was a technical study of 19th century French Impressionist and Post-Impressionist paintings from the museum holdings. I also collaborated with Northwestern University, and specifically with Richard Van Dyne's group at the chemistry department, again, continuing to develop non-destructive source methodology for the analysis of dyes. Between 2014 and 2016, I was first a postdoctoral science fellow and then an assistant conservation research scientist at the Guggenheim back in New York. So the Guggenheim had a very strong conservation department, but no scientists on their staff or scientific research facilities to conduct technical studies of objects in their collections. And so this was a wonderful pilot program, also in collaboration with the Met DSR, trying to establish a framework for science and science-informed conservation where none existed before. I went back to the Met Department of Scientific Research in 2016, where for 5 years I was an associate research scientist, and I led a wonderful initiative called NICS, the Network Initiative for Conservation Science, that was mentioned before by Francesca, whose goal was to provide analytical assistance and scientific support to a core group of partner institutions in the city of New York that, again, didn't have scientists on their staff or research facilities for technical studies of their objects. And so we had a chance to collaborate with 11 museums in the cities. They include the American Museum of Natural History, the Guggenheim, MoMA, and many others. I moved back to Italy after 11 years abroad 2 years ago in July of 2021 to work at one of the 3 conservation centers in the country, the Centro per la Conservazione e Restauro dei Beni Culturali, la Venaria Reale, where I currently serve as director of their scientific laboratories. So I'm sure we will get a chance to discuss further about this and the importance of the education that we got at the Italian university. In my case, I think what I want to say, it's been very interesting for me to reflect on my own journey. That's been some sort of a circular journey. So because of my strong scientific background that I acquired at the Italian university, I was able to secure my first position at the Metropolitan Museum, and then I had many other opportunities after that for the next 11 years. And then because of the great experience that I acquired working in many US museums, I was actually offered a position back in Italy at the Centro Conservazione e Restauro. Okay, so coming to my case study, I'm going to speak about a technical study of 15th century Italian illuminated tarocchi cards. This has been a great project, very much international, multi-institutional, and with a highly collaborative component. There are many people, many great colleagues and friends and institutions as well that I need to mention that are currently partners of this project, such as the Morgan Library and Museum, Yale University, the Metropolitan Museum, the Centro Conservazione e Restauro, la Venaria Reale, as well as the National Gallery of Art and the Art Institute of Chicago. As you probably can tell by looking at this timeline of research activities and collaboration, the research project has been going on for quite a few years now. It all began from an informal conversation back in 2016 between 2 conservators, a conservator at the Morgan Library in New York and a conservator at the Beinecke Library of Yale University. The research project grew over the years to become a fully fledged a pretty complex research project that survived the global pandemic starting from 2020 and is still going on today in 2023. So I thought I'd start with the definition of the term tarocchi that we now use in a completely different meaning compared to the 15th century. So back in the 15th century, the term tarocchi was used to indicate a trick-taking card game that appeared for the first time, again, in the first half of the 15th century in northern Italy. So the term tarocchi was not used to indicate divination activities until the end of the 18th century. And conventional tarocchi decks actually contain 78 cards divided between pip cards of the 4 different suits, so cups, coins, batons, or staves, and swords, court cards, including the king, the queen, the knight, and the page, and the so-called trump or tarocchi cards, including, for example, the emperor, the fool, death, sun, and many others. So these are the 3 tarocchi decks that I'm going to focus on today. They're collectively known as Visconti Sforza tarocchi decks. They're divided between United States and Italian collections, and in particular, the Visconti di Modrone deck is at Yale University at the Beinecke Library. The Brambilla deck is at the Pinacoteca di Brera in Milan. And the Visconti Sforza or Colleoni Baglioni deck is divided between the Morgan Library in New York and the Accademia Carrara in Bergamo. None of these decks is a complete deck of cards. As you can see on this slide, the Visconti di Modrone has 67 extant cards, the Brambilla deck has 48, and the Visconti Sforza has 35 at the Morgan and 26 in Bergamo. So these decks are collectively attributed to Italian artist Bonifacio Bembo and his workshop, who is believed to have created them between 1331 and 1358. There are 6 so-called replacement cards that you see at the bottom of this slide. 3 are held by the Morgan and 3 are at the Accademia Carrara in Bergamo. So these are cards that were produced to replace cards that have gotten damaged or lost over time. And they were produced by 2 different artists, Antonio Cicognara, or more likely Franco di Giovanni de Russi, most likely a few decades after the regular Bembo cards. We're looking at a very important commissioning, so the Dukes of Milan, specifically Filippo Maria Visconti and Francesco Sforza. So what was the goal of our research project? We wanted, first of all, to identify and compare the materials and techniques of the 3 so-called Visconti Sforza tarocchi decks in the different United States and Italian collections, going through their layer structure, so studying the paper support, the preparatory composition, the ball and the metal leaves, the gilding and tooling, the color palette, and highlighting any potential later intervention. We also wanted to compare the materials and techniques with 3 different artistic productions that are believed to have affected the materials and techniques of these decks that are fresco painting, manuscript illumination, and panel painting as well. So overall, we just wanted to contribute to the ongoing conversation about the provenance and attribution of these decks. And also we wanted to verify whether different attributions could correspond to a different use of the materials and techniques. For the purposes of these talks, I'm just going to focus about some of the main results that we obtain on US cards, so mostly Yale and Morgan decks. Here's a brief overview of the analytical methodology and instrumental techniques that we were given access to for this technical study. So as you can see, it was a complex analytical methodology that involved non-invasive imaging techniques, non-invasive point techniques, the removal of a selected number of microscopic sample, and analysis with minimally invasive instrumental techniques as well. So in the next few slides, I'm just going to give you a very brief review of the main highlights of the main results that we were able to obtain, again, going through the layer structure of these wonderful objects. So we discovered that both Yale and Morgan cards were made on pasteboards that were fabricated by layering and gluing together 4 to 5 sheets of paper. As you can probably see from this figure, the back of the Yale cards was left bare, while the back of the Morgan cards was painted red with an organic colorant called sapanwood. We detected 6 similar watermarks on the Yale cards, and all these watermarks matched watermarks found in repositories within a 400-kilometer radius of Milan, and they were all dated between 1337 and 42, which of course is very important to reinforce provenance and attribution. We couldn't find any watermarks on the Morgan cards. In terms of preparatory composition, we highlighted the presence of a series of sequential steps, starting with a loose underdrawing that was executed with lead point. That was likely followed by an ink underdrawing that was probably made to refine the preliminary sketch. We found a series of incisions in the paper, probably created to outline certain compositional elements. And incisions and tooling was also made after the metal leaf was applied, and that's particularly clear when we analyze these cards with RTI and also visible photography in breaking light. There was a thick ball layer that was used to adhere the metal leaf to the paper support. In both decks, this ball layer was composed of an iron-rich clay mixed with or applied over gypsum. And as you can tell from the Mercury XRF elemental map that I reported here, the Yale deck is also characterized by the presence of vermilion that was probably added to the ball formulation to impart a certain tone to the metal leaf. The most interesting results were obtained in terms of application of the metal leaf to the different decks. So just by looking at the gold and silver elemental maps that I put on this slide, you will probably notice some substantial differences between the two decks. So the figure cards refer to the Yale decks are gilded with small pieces of gold leaf. You will probably see they partially overlap each other, and they were applied around each figure and shape very carefully. The Morgan figure cards at the bottom use an entirely different material. So you see there is a gold and a silver overlapping distribution in the XRF maps, which indicates the use of a so-called oro di metà, which is a particular material of which 15th century Milan was known to be a big center of production of. So oro di metà was made by hammering together very thin leaves of gold and silver into a single leaf. If we look at the pip cards at the center of the slide, so Yale cards are made with silver leaf, and the Carrara Morgan cards are made with lead white, while gold was only used to outline certain small details of the different suits. Over to the right, you can observe some beautiful micrographs that I've taken of some of these cards, highlighting the decoration that was made with punch marks of different shapes and freehand incised lines as well. We've done quite a lot of work also trying to identify the pigments and colorants that the Tarocchi artists used. And to do so, we combine different elemental, electronic, and vibrational techniques, mostly point and scanning XRF, reflectance imaging spectroscopy, and Raman and SIRS spectroscopies as well. So over here, I just report some of the most representative XRF elemental maps that indicate the presence of pigments containing mercury, iron, lead, tin, cobalt, and copper. These data were integrated by RIS analysis that we used as a preliminary step for Raman and SIRS. So by now you know everything about this technique thanks to Francesca's talk, but basically what you're looking at is some spectral end members that can be used to produce a false color map that you see for these two cards at the left of this slide, that basically indicate the distribution of different inorganic and organic materials as well. In our case, it was interesting, for example, to put forward hypotheses in terms of differentiation between plant-based organic colorants and insect-based organic colorants. And we were able to verify our hypothesis by using vibrational analysis with Raman and SIRS. So again, over here, you're just looking at some of the most representative Raman results that we were able to obtain. So we found many different inorganic pigments representative of many different colors. So vermilion for the orange and red, Latin yellow type 1 for the yellows. A tin sulfide, mosaic gold, which was a brown pigment that we only detected for the 6 replacement cards. So that was interesting. A mixture of yellow and red ochres for some of the dark yellow highlights. A combination of 3 different blue pigments, azurite, lapis lazuli, and smalt, that were often used in combination and in a very much of a complementary way, as you can see from the combined cobalt and copper XRF map at the bottom. And then for green colors, we detected malachite, an unknown copper-based pigment, together with Latin yellow type 1. So especially the Morgan cards, as opposed to the Yale cards, display a wide variety of red, purple, and violet colors that were mostly of organic nature. So using SIRS, we were able to conclusively identify 2 plant-based colorants, sapanwood or verzino, and folium or morella, and 1 insect-based dye as well, kermes or grana. And again, this is something that I really want to mention because SIRS is a technique that I really focus a lot of my years on, especially during my PhD and during my early years of postdoctoral research. So using, again, a combination of analytical techniques, we were also able to detect some red lake pigments that have now disappeared. So for example, if you look at the 10 of batons in the Yale deck to the right of the slide, you will probably see in the close-up here at the bottom, a series of very fine incised lines in the shape of feathers surrounding the golden part of the batons. If you look closely, you won't be able to detect any trace of red lake, so the colorant is mostly gone. But if you look at the potassium map, you will see a distribution of potassium in the shape of feathers that is really indicative of the substrate, the inorganic substrate used to make the red lake. So in collaboration with our colleagues at the Art Institute of Chicago, we've done a lot of organic analysis. So we've done FTIR, preliminary analysis, just to understand the generic molecular class of the binders and glazes that we were looking at. And then using mass spectrometry-based proteomics, PyGCMS and MALDI, we were able to detect protein-based organic binders containing chicken whole egg for both the Morgan and Yale decks. After I moved back to Italy in 2021, I was able to involve some of the Italian museums that hold tarocchi decks in their collection, so the Pinacoteca di Brera and the Accademia Carrara in Bergamo as well. So there has been quite a lot of work done on those tarocchi as well over the past 2 years. So what you're looking at over here is just a selection of pictures from some of the analytical campaigns that we had in the Centro Conservazione e Restauro back in June of 2022 when a selection of 15 tarocchi cards from Bergamo were shipped to our institution for in-depth scientific analysis. And then in April of last year, we received the visit of a small group of colleagues from the Morgan, from Yale, and from the Met. They came to visit us so we could study the cards together. And between June and October of 2022, we also conducted a couple of in situ analytical campaigns of the Brambilla deck in Milan at the Pinacoteca di Brera. We are now in the process of interpreting the results, but I'm just going to give you a little spoiler here. So if you look at this card, the 3 of staves, from the Accademia Carrara deck, we detected a very thick carbon-based underdrawing that is not present in any of the other cards that we analyzed. And we also identified a series of very unusual materials, like, for example, organic yellows, and a combination of red ochres and vermilion at the back that we didn't find in the rest of the deck. So all these observations made us think of possibly a different hand and time of production of this card compared to the rest of the deck. We've been disseminating our research findings. So a Tarocchi virtual study day was organized back in June 21st of 2021 that was attended by more than 200 people. For those of you who are interested in learning more about this project and would like to hear the talks that were given at the study day, I invite you to check out this link at the top of the slide. We are now in the process of publishing our first article describing especially the aspect related to collaboration of this wonderful project. So the article will be published hopefully by the end of the year and available to everyone to read on the Material Getty Journal. And many, let's say, technical articles will be published hopefully in the next few weeks and months. We've also talked about possibly holding a joint exhibition of the Tarocchi decks sometime in the next 3 years, hopefully in 2026, so stay tuned for more updates. It was just me today talking about this wonderful project, but of course it takes a village, especially when we talk about such complex projects like the Tarocchi research project. So I have many colleagues, friends, and institutions that I would like to thank for the wonderful work that we've done together. And I also want to thank Marco and Francesca for giving me many great opportunities over the years and for being wonderful mentors to me. And of course, thank to you for your kind attention.
Thank you, Federica. I think we're at the end of this afternoon session, and looking into the break, I just wanted to say a couple of words, even though Marco and Gennaro officially will close us, but I am absolutely thrilled because all of the speakers suggested their own topics, and I think that today, I hope you will agree, we've seen a breadth of techniques, objects studied, and interest that is quite astonishing. And at the same time as the excellence of the science that has been presented, really wonderful. And also the interesting part, I think, that has been elevated for me is the importance of the 3 C's: collaboration, communication, and curiosity. So I want to definitely extend my thanks to all the speakers of today, especially, I have to say, the remote speakers that are not benefiting from this beautiful setting we have in Rome, and myself personally thanking Gennaro Marino and Antonio Sgamellotti for inviting me to be part of the conception of this gathering. Don't go away, just keep thinking about these things, because then Marco will lead us in a panel discussion just after the break. So we will reconvene here in about 20 minutes. Thank you.